We're going to look at undoing trig functions. To undo a sine or cosine or a tangent, we would use your arcsine or arccosine or arctangent. Your arctangent would undo your tangent. They're just inverse operations like multiplication and division or addition and subtraction. Now, there's two different ways to write arcsine. Either arcsine or capital S with a sine inverse. Capital sine inverse or arcsine is only defined in quadrants 1 or 4 and only from negative pi over 2 to positive pi over 2. So that means if you have any answer in quadrant 4, you would need to start here and rotate down to get the answer in quadrant 4. If you started here and rotated all the way around, you would get the wrong answer because it says you need to start at 0 and rotate backwards to pi over 2, which is rotating this way. Same idea for that goes with the tangent stuff. If you have anything in the fourth quadrant, you got to start here and rotate down. Now, arc cosine is also capital C cosine inverse, and arctangent is capital T tangent inverse. Make note though that your cosine here is in a different quadrant. It's in quadrants 1 and 2. So your cosine is here and here, where your tangent is here and down here where it's green, along with your sine being here and also down here. So let's take a look at a couple of problems. We need to solve, and in this case it says for degrees. So they're not looking for radians, they're looking for degrees. This problem here could be written as this and mean the exact same thing. Both of these statements are identical in meaning. But the sine of what angle is root 2 over 2? And since it's capital sine, that means you need to be dealing with quadrants 1 and 4. So in quadrants 1 and 4, 1 is sine equal to root 2 over 2. And well, that's just 45 degrees. It's one you're supposed to have memorized. Here we have our cosine of what angle is root 3 over 2. But notice it's capital C. So it could be written like this and mean the exact same thing. Remember that cosine inverse is defined to be in quadrants 1 or 2. So in quadrants 1 or 2, when is cosine equal to root 3 over 2? And that is 30 degrees. Now we're going to solve for our angle in radians, not degrees. Now, we have this right here, arc sine of root 2 over 2. That means the sine of some angle is root 2 over 2. In other words, your arc sine of root 2 over 2 is just representing an angle, and we're just trying to find that angle. But it means the sine of some angle being root 2 over 2. And remember that sine inverse, arc sine, is defined in quadrants 1 and 2. So when in quadrants 1 and 2 is your sine root 2 over 2? You might say 45, but remember we're working with radians, so it's pi over 4. So let's take a look at the next one here. It's a little bit more complicated looking, but keep in mind we have tangent, and then this right in here is cosine inverse of 4 over 5. Cosine inverse, any inverse trig function is always an angle. So everything in the parentheses is representing an angle. I'm going to just call that angle x. So in other words, if this whole thing here, which is an angle, and I call x, I'm really looking for just tangent of x. But first of all, we got to go ahead and draw ourselves our angle. Now, what we have here in black, right here, means the cosine of some angle, which we're calling x, is 4 over 5. So what we have right here is identical in meaning to this. So cosine's defined to be in quadrants 1 or 4, 1 or 2. Which one of those quadrants is cosine positive in? In quadrant 1. So that's why I have an angle down here drawn in quadrant 1. Now, remember, you always want to go ahead and draw yourself a triangle, but it needs to be always going to the x-axis. So we then have our cosine being adjacent of 4 over our hypotenuse of 5. So that's why this side's 4, this side here is 5. My angle is x. I can use the Pythagorean theorem to figure out this missing side. And that's what we were doing down here. Your 5 squared minus your 4 squared inside your square root is 3. If you didn't know it, that's how we would come up with it. Now, according to our problem up here again, we're looking for the tangent, and this whole thing is an angle, so we're looking for the tangent of our angle. So we're going to go down here to our angle and do the tangent. Remember, tangent is opposite of 3 over adjacent of 4. And so we get 3/4. Whenever you have a trig function with another trig function in it where one of them's an inverse, you always want to work from the inside out. So we're going to do the same thing here. We're going to go ahead and work from the inside out. This is just an inverse trig function. It's an inverse trig function, so this right here means the tangent of some angle, which I don't know what it is right now off the top of my head, is a root 3 over 3. So that's one you're supposed to have memorized. When is tangent equal to root 3 over 3? Well, that's at pi over 6. So the whole inside right here, highlighted, represents the angle of pi over 6. You now just want the sine of pi over 6. That's one you're supposed to have memorized, and you get 1/2. Looking at this one over here, once again, we want to work from the inside out. So we'll go ahead and work from the inside out. In this case, it's not an inverse trig function. It's just a normal tangent. Tangent pi over 4, you should remember, is 1. So now it's the sine inverse of the outside, the whole inside simplified down to 1. That means the sine of some angle, which we don't know yet, that we're trying to find, is equal to 1. Well, when is sine equal to 1? Remember, sine's the y-coordinate, and that's at pi over 2. Well, here we need to solve this one by using an inverse trig function. If we do our inverse trig function, we can go ahead and apply the inverse trig function to each side, so tangent inverse of this side. And then we'll do the tangent inverse of the other side. So your tangent and your tangent inverse on the left undo each other, leaving you with A. On the right, it's just tangent inverse of B.